Hi everyone and welcome back. I hope you're all staying safe and doing well. So we have concluded our unit on quadratic equations. Now we're actually going to start taking a look at what's called an exponential function. Okay, so we've actually encountered some of these questions in Plicker's cards, and now we're actually going to see what they look like. So let's take a look. And you'll all have this packet posted in Remind. It will also be available on Unified Classroom for you to access. So, very first thing, I do want to do a little bit of an exploration here. Okay, exponential functions, they follow this general shape. So the graph of the exponential function, we can type into our graphing calculator. So I would pause the video here and I want you to type all 4 of these into your calc. Do them separately, do them one at a time. And I also want you to tell me if you notice anything. Now, for those of you that are asking, well, how do I type this into the calculator? I want you to go to y equals on the calc. You're going to type 3, those open parentheses, 2. You're going to hit the caret button. Remember that caret button looks like this. So you're going to hit caret x, and then your x will appear up here, and then you'll move your cursor to the right to get out of the exponent. Okay? And just so you know, this caret button here to get an exponent, that is right below where it says clear on the calculator. So there's a clear button. And then there is also the division button. So it's in between those two pieces. So this is what we want. We call it a caret. All right, so let's see what you get. So when I graphed my first equation for number 1, I ended up getting that matched graph A. So it followed this path. Okay, so that matched A. For question 2, I found that to match letter C. So it follows this kind of trend. Okay, for question 3, I found that to match letter B. So it looks something like this. And then for question 4, our last one would be letter D. All right, so this is what my graph looks like when I graphed all of them on the graphing calc. Again, if you didn't get those, please make sure you go back and actually type those in. And again, all 4 of these graphs display an exponential function. So these are all exponential graphs. Okay, so just keep that in mind. It has to take on this shape. Y equals AB to the X. And I'm going to explain what A and B are very shortly. All right, so let's keep going. We have an exponential function is in the form of y equals AB to the X, which I just said previously, where A is going to be the initial amount. And if you guys think about that. What would the initial amount or the initial value represent on the graph? Like, what would that look like graphically? If that's my initial amount. Think about when we were talking about with quadratics, when we had the initial height something was being thrown. Okay? That initial amount or our initial height, to put it in perspective, that's always going to be our y-intercept. Okay, so A in this case is going to represent also the y-intercept. And B is going to be our base value. So that's going to determine, our value for B is going to determine whether it's an exponential growth or decay. All right, so now some new terminology here, really important. The line that the curve approaches but never reaches, we call an asymptote. Okay, the asymptote of an exponential function is a horizontal line. It's written in the form of y equals a number. Okay, so for example, if this had a value at 2, my exponential graph is going to approach the line y equals 2. So this would be my horizontal asymptote. Okay, so if we had, again, this was the line y equals 2, I'm just making up a number, that would be where our horizontal asymptote is. The graph is never going to cross. It's never going to go like this. That will never happen. It's not going to cross over. Okay? All right, let's keep going. All right, so just continuing to scroll down. The next piece says, for each of the following, state the values of a and b, and then we're going to evaluate f of 2, f of 0, f of -1, and then find the y-intercept. Okay, so we just got to go back and think about this vocab. So if you need to pause the video to make sure you're referring to the top of that page or the middle of the page for the vocabulary, really important. So a, remember, the form for an exponential function is y equals ab to the x. Where a, what does a represent again? I don't remember. Okay, a is that initial amount, and it's also the y-intercept. So we already know the y-intercept is going to be 7. So a is 7. B is our base value. So here's b, and that's my 0.9. Okay, now we have to remember, guys, what function notation is. This is function notation if I have f of something. So f of x, remember, that equaled y. X is what's inside the parentheses. So for f of 2, our x value is 2. For f of 0, our x value is 0. And for f of -1, our x value is -1. So now let's actually evaluate these. Again, remembering we're plugging in for x. And now in this situation here, x is our exponent. So we're going to be plugging in to the exponent. Okay? All right, so let's do it. We've got, for the first example, I have f of 2. And now we're just going to evaluate by plugging it in. And I have 7 times 0.9 raised to the second power. And again, guys, you just got to type that into the calculator. So the way we type that into the calculator, this is going in on the home screen. On the home screen, we're going to type 7 parentheses 0.9. Use the caret button. Use that caret button. And I'm going to type in 2. So it will look like this. All right, and when I put that into the calculator, I ended up getting 5.67. Okay, and we already said our y-intercept before, that's the a value, so that's just 7. All right, I'm going to clean this up a little bit just to kind of finish up this example. So just give me a sec. Okay, now I want to look at when we have f of 0. So f of 0, again, we're plugging in x to equal 0. So here's my original equation. I have 7 times 0.9 to the 0. Plug that in the calc, and you get 7. Now, you should have actually known before even doing this that the answer was already 7. Why? Why should I have known before even plugging this in that the answer was 7? Think. If x equals 0, well, that means if x is equal to 0, okay, if I create my axes, we've got -1, 1, etc. So x is 0, well, I can't be moving left and right. I'm only moving up and down. So if x is 0, that means my y value is going to lie along the y-axis, which will give us our y-intercept. And we already know the y-intercept is 7 because our a value represents the y-intercept. Okay? All right, let's keep going. Now I'm going to post the solutions for the rest of these just so you guys have them if you decide to do them for extra practice, but I only wanted to go through those 2 examples. All right, so if you want to pause the video here and finish those up, I'll post the answers now. All right, and there you have it. Those are the rest of our answers here. Okay, so we're just going to move on. I'm going to scroll over to the next page. So now I want us to start graphing these. Okay, so again, let's identify our A, B, and C values. Here we have A, here we have B, and then X. I'll do that for the same one over here. Here's my A, here's my B, and here's X. All right, so let's fill it out. So A, again, we have Y equals A, B to the X. All right, So our A value, as we said here, is 3. Our B value is also 3. Remember, A is equivalent to the y-intercept, so this is also 3. Now, we have to come up with the domain. But before I do that, I actually want to graph this. And we're also going to take a look at what the range is as well. So I'm going to add that in. So what you guys should do is, on your calcs, I want you to graph this. So go into y equals and graph these points. Okay, so I would pause the video here and see if you come up with the same values as me when you graph it. Okay, now, so hopefully we graphed some of these points. Now, you always want to graph mostly as much as you can. I usually try to graph the nice numbers. Okay, so if you look on your calc, you'll see some crazy decimals on there. I just prefer to go with the nice integer values and whole numbers. All right, so now I got to connect my points. So let's start connecting our points. Remember, we have to have arrows on either end. Okay, now you got to be careful here. Now I'm going to start connecting this point to here. Should I cross over the x-axis? Some of you are shaking your head no. Why not? Good. We can't cross over the x-axis. This is an exponential function, so there's an asymptote. So you want to be careful. Do not cross over this x-axis. We would have an asymptote at y equals 0. So now we got to come up with domain and range. Well, I want you guys to visualize this. The domain is always talking about the x values. So domain is our x values. Range is our y values. So let's take a look at the domain. Well, let's look. My x values are going all the way to the left, and they're going all the way to the right. Right? These x values are still continuing to the right. So my domain here is actually going to be all real numbers. I'm going all the way to the left and then also all the way to the right. Okay, well, now let's take a look at our range. Now, range talks about the y values. Well, we have an asymptote here at y equals 0. That means this exponential function is never going to cross over the x-axis, so when y equals 0. Can I equal 0? No, we just said you can't cross over the x-axis, so it's not going to touch the x-axis. There's this little barrier here. You can't cross over the x-axis. So if I can't cross over the x-axis and all my y values are going up and up and up, well, I'm looking at when y is greater than 0. Okay, so that's my range. Now I want to take a look at question 8. Again, just to recap on question 7, this is an exponential function. And now I do want to actually introduce a new piece here that I didn't talk about yet. You probably heard me mention before, exponential functions are either a growth or a decay. Well, if you look at my graph here for number 7. As we read from left to right, is my graph increasing or decreasing? So as I read from left to right, this thing is increasing. So this would be considered a growth. Okay? Now, a big reason as to why this is a growth. So I'm going to include that here. Now, the reason why this is a growth is because our b value, the reason why this is a growth is because our b value has a rate that is greater than 1. So our b value is greater than 1, which means it's a growth. All right, keep that in mind. If our b value is less than 1, what do you think that's going to mean? It's a decay. Very good. All right, so when your b value is greater than 1, which it is here, we're dealing with a growth. If my b value is less than 1, which is actually the situation here, I'm going to be looking at a decay. So that means as I read from left to right, I expect this graph to decrease because it's a decay. All right, so let's do it. Let's take a look. I want you guys to graph question 8. I'll write some points up here, my x and y values, and let's see if we get the same solution. Fill out your a, b, the y-intercept, domain, and range, and let's see if we get the same thing. Pause the video here. All right, so here are just a few points that I plotted. I plotted the -1, 8.3, that's repeating. I put 0, 5, and then 1, 3. Okay, so there are going to be some situations where we're going to have to graph decimal points just so we can get a clear picture. But when in doubt, if you can, try to go with those nice integer whole numbers. And if it doesn't work out, please make sure you graph other points. All right, so I'm going to graph these 3 points here, which I did. And I'm going to start to connect them with a smooth curve. Do not connect them with a straight line. This would be wrong. Okay, so now I'm going to connect them with a nice smooth curve. Remember the pathway of an exponential function. It needs to be a nice smooth curve, so I'm going to connect my points here. Should be curved. Should also be curved. Okay, so it looks something like that. Now I do just want to go back and refer to what we said before. Again, our a value is 5 because that's what's highlighted in red. We got to follow the order as we have it here, right? We have our b value is 0.6, and our y-intercept is 5 because that's equivalent to the a value. Domain. Now, the reason why I came up with the domain to be all real numbers is because as I travel right and left, all of my x values are included. As I go from right to left, all x values are being included. Now, when it comes to range, you got to remember, we're looking at the y values. And the y values here, for the asymptote, we know the asymptote exists at y equals 0. So this graph cannot, and I'm going to draw something incorrect so you get the example, this cannot cross over the x-axis. That would be wrong. This cannot cross over the x-axis because of the asymptote. So accuracy in these graphs are important. Okay, so as I was mentioning before, we're looking at range. So it's not going to cross over the x-axis, so it can never equal y, but I'm looking at all the values greater than y. All of these values are positive y values, and they're all above the x-axis. So that's why my range is y is greater than 0. Now to talk about this being a growth or decay, as I said, I predicted because my b value is less than 1, because my b value is less than 1 right here, I expected this to decay, meaning it would decrease as I go from left to right, which it does. I decrease as I go from left to right. Okay, so huge pieces here, and I'll reiterate them again. All right, so I'm going to flip over to the next page, and I'm going to take a look at question 11. So question 11, we want to know about this exponential function. So I would pause the video here and type that into your calculator. So pause the video here, type that equation into your calc. All right, so here's my rough sketch of this graph. I kind of just wrote down the data table values so you can check to make sure you typed your equation in correctly. Now, first thing I'm going to write down is, again, we need to remember the equation for an exponential function, where a represents what again? Good, the y-intercept, or the initial amount. B represents what? Good, the base. What happens when b is greater than 1? What does that mean? Is that a growth or a decay? Good, it's going to be a growth. What about when b is less than 1? What does that mean? It's going to be a decay. Very good. All right, so let's delve into this here. So based on our equation, now you might be noticing something missing. I have y equals 2 to the x. And we need to follow this equation of y equals ab to the x. So here's x, so that lines up with x. Here's b, because it's attached to x. B is attached to x. I don't see what a is. What's a? If I don't see it, guys, and it's out front of b, what's a? Good, it's 1. A is actually 1. So in this case, what's my y-intercept? If a is equal to 1, what's my y-intercept? Good, 0, 1. Okay, careful of that. Regents likes to do that. All right, domain. So the domain for all of our exponential functions is always our all real numbers. So that's going to be answer choice 3. We're going from negative infinity to positive infinity. All right. Don't forget those parentheses means not including. Parentheses means not including. The hard bracket means including. And now the reason why we don't have a hard bracket on infinity is because you can't ever actually reach infinity. Can't reach infinity. All right, so hard bracket means include, and the soft bracket or the parentheses means not including. All right, so hopefully that helps clarify. Okay, range. So now we got to take a look at the range. So if we look at our graph here, look at all those y values. All of our y values are positive. We can't cross over the x-axis because of the asymptote at y equals 0. All of the y values are above the x-axis. So all my y values here, they're all positive, which we could tell from our graph. All of our y values, they're positive. So all of my y values will be greater than 0. And the only option for that would be answer choice 1. We're going from 0 to infinity. Okay, because remember of that asymptote. Going from 0 to infinity. All right, let's take a look at the next one. What is the asymptote? Well, we just said it. It's always y equals a number, and the number just so happens to be 0. Now, why is the asymptote 0? So I'll add for a little piece here for us. Our equation is the following. Y equals AB to the x. The asymptote is whatever the vertical shift is. So in this case, it's plus 0. It didn't move at all anywhere. So that's how you know what your y asymptote is. So the asymptote is at that vertical shift. And in our case, there is no vertical shift. Didn't move up or down. So our asymptote is just at y equals 0. And you'll see some examples where the asymptote is not at y equals 0. Okay? All right, let's continue to move on. I would encourage you to do question 12. So I would just pause the video here and try question 12 on your own. Make sure you read. Definitely make sure you read. All right, so there you have it for question 12. Those are your answers. So I would just double check and make sure you got the same thing as me. All right, so let's scroll down to question 13. So question 13 says, which answer choice is an exponential function of the form, again, f of x equals ab to the x, so we got to remember that. We have y equals ab to the x, and I'm going to color code. We've got y equals ab to the x, okay? To figure out what is the graph displayed from the chart. All right, well, let's see what we got. Our y-intercept, so the y-intercept is always when what equals 0? Is it x or y? If I want the y-intercept, if I want to fall along the y-axis, what always has to equal 0? Has to be x. So that's when x equals 0. Okay, so here is where x equals 0. I have my y-intercept is at 2. Remembering that a represents the y-intercept. So a represents the y-intercept, so let's write that down. Remember, y-intercept. So I've got y equals 2 times, well, what's b? Now, b is talking about this rate. Like, how is this thing growing? Well, when I talk about exponential, guys, we're talking about factors. It's being multiplied by something. So let's see. And it's always going to be multiplied by the same amount every time. So now notice I'm missing a value in here. I'm missing when we have 2. So I'm actually going to add that in. I did it on purpose. Because if we look, 2 times what gets me to 6? 2 times 3. 6 times what will get me the term that's missing here? So 6 times 3 will get me that term that's missing. Well, if I multiply it by 3, this will be 18. And what's 18 times 3? 54. So we know this thing is growing at a rate and factor of 3. So there's your b value. It's being multiplied by 3. So there's my equation. Should be answer choice quattro. All right, let's keep going. Let's move on. Okay, now I want to take a look at question 14. And before we begin this, I want us to note, I'm going to write this over here just because I don't really have a whole lot of space, so I'm going to write this down here. This has nothing to do with domain and range. I just want to write this out to point out a few things. So I have y equals 2 to the x minus 1. Now, this is new, this minus 1 here. If you guys think about our transformations when we were shifting things, there are no parentheses here. So how is this thing being shifted? It's moving down 1. Moving down 1. So I want you guys to think back to what I said. When we have y equals ab to the x, it's really y equals ab to the x plus 0, because this is always going to be my horizontal asymptote. So there's your asymptote. So in this situation, if I have y equals 2 to the x minus 1, what do you think your asymptote's going to be here now? Good. Your asymptote is going to be y equals negative 1. So this thing is not going to cross when y is equal to negative 1. Just wanted to point that out. Okay, so this is something you guys can type into the calculator and graph, but I just wanted to make sure that we're being mindful of the fact that now the asymptote's at negative 1 because of this vertical shift. It's being shifted down. All right, so why don't you guys pause the video here and graph some of these points, and we'll come up with domain range. We'll come up with the equation for the asymptote, which we actually already stated. You're going to tell me if the function's always increasing or decreasing, and then you're also going to state the zeros. So pause the video here and give 14 a try. All right, so now that I plotted my points, I'm going to connect them with a smooth curve. All right, so start to connect them with a smooth curve. Don't forget the arrows. Again, be careful graphing here. You do not want to cross over the asymptote. So what I did right here, this would be wrong. You can't cross over the asymptote, so let's fix it. Okay, so it should look more like this. I'm going to try to make this nice and smooth. Don't cross over the asymptote. Okay, so there's my exponential graph. All right, we want to state the domain and the range. So domain, again, for all exponential functions. So the domain we know is all real numbers. If we wanted to write that as negative infinity to positive infinity, that's also acceptable. Your range, now be careful, it's not y greater than 0 like it has been. That's wrong. Because I want you guys to look. What is the value that this graph tends towards? Like, what does this graph get really close to but can't reach? And we said this actually before we even began plotting any of this. We said that this is never going to reach negative 1 at y equals negative 1 because that's our asymptote. Remember, the asymptote is that vertical shift. It's shifted down by 1. So we know our range is all y values. So look at my y values. All of my y values are greater than negative 1. They're all getting bigger than negative 1. Okay, so now let's take a look at the equation for the asymptote, which we already discussed. So we're just going to write the equation for part B. The equation is that y equals negative 1. Okay, the next part, part C, says, is the function always increasing or always decreasing? So let's take a look. Is the function always increasing or decreasing? Well, as I go from left to right, is this function always increasing or decreasing? As I go from left to right, good, it's increasing always. All right, so we're going to write that it's always increasing. I don't know what's going on, why this is not staying where it should. But we would have this is always increasing. So I'm going to just highlight over here, always increasing. Why do we know that this thing is always increasing? Because, remember our equation, y equals ab to the x. Our b value is bigger than 1. Our b value is bigger than 1. All right, and then lastly, state the zeros. The zeros, guys, is when it crosses the x-axis, and that's at this point right here. There's my 0 at x equals 0. Okay, hopefully you guys found this video helpful. This is about everything I wanted to cover. If you want to stay tuned to try question 15, I think that would be a good help for all of you. Just some extra practice, okay? And you guys will have 2 days to watch this video over, all right? So stay tuned if you want to continue. All right, so we're going to graph question number 15 here. So if you guys want to pause the video and type that into your calculator, let's do it. And I'm going to graph some of those points here as well on the side. All right, so pause the video here and graph that exponential function. All right, so that's what my point should look like. Remember, we're following this equation, y equals ab to the x. And now I write that plus 0 because this 0 means that the asymptote is going to be at 0. So I don't see this equation of y equals 2 to the x plus 1. It's not being added by anything here. So that means we can write 0. It's really just being added by nothing. So there's no shift of any kind vertically. So I'm going to draw in my asymptote at y equals 0. Okay, and I'm going to connect my points with a nice smooth curve. You do not want to cross over that asymptote. All right? There we go. So there's my nice smooth curve. So there's my exponential function. Now, as I look at this thing, as I go from left to right, is this thing increasing or decreasing? This is increasing. And now that should make sense because what did I say before? This is increasing. Again, this should make sense because what's my b value? Well, my b value is attached to x, so my b value is 2, and this is greater than 1. 2 is greater than 1, so it's growing. This is an exponential growth. Okay? All right, so now let's take a look at domain and range. So we have domain is always going to be our all real numbers. So let's write that in here. Domain is all real numbers. Okay, so that's negative infinity to positive infinity. My range, well, all my y values are bigger than 0. Okay, now let's come up with the equation for the asymptote, which we already said. We already said the equation for the asymptote was at y equals 0. Okay, we already said that this function was always increasing. So I'm just going to circle, it's always increasing because, again, remember that b value is greater than 1. It's a growth. So it's always increasing. Okay, and then lastly, is the function always positive or always negative? Well, let's take a look. The function is always going to be positive because look at all the y values, guys. All these y values are positive. They never cross below the x-axis. Remember, we said that that would be wrong. So all these values are positive. It does not cross below. So this would be wrong, okay? So it's always positive. All right, so I hope you guys found this video helpful. Again, you have 2 days to watch this video over, giving you guys some extra time at home to watch this whenever you have the time to do so. All right, just remember, I said I'm more than happy to hold Zoom sessions over our class period times. All right, hope you guys have a great day. Talk to you soon.